Looking at problem 31, it's a question where you have to choose the correct statement about the characteristics of longitudinal waves. You can think of longitudinal waves as having the same characteristics as sound waves. If we look for the correct answer right away, I can tell you that it's choice D. The characteristic of longitudinal waves is that the particle motion moves in the same direction as the wave. On the other hand, movement that is perpendicular or vertical is related to the characteristics of a transverse wave, not a longitudinal wave. In the case of A mode, only sagittal images are produced. Yes, you can see that this is an incorrect option. Saying that it moves randomly is also unrelated and can be explained as such. Next, some people tend to get confused with option C. The acoustic velocity, or the speed of sound, is indeed 1540, but it does not remain constant. It can vary depending on the medium. Please remember this difference based on this sentence. Now, let's move on and look at question number 32. If you look at the sentence, it says that the renal cyst was examined and measured at 35 millimeters. This question asks you to choose the option that has the same value as the one given here. Simply put, it's a unit conversion problem. You can think of this as a straightforward problem pattern that can be solved easily. The correct answer would be option C. 35 millimeters is equivalent to 3.5 centimeters in terms of units. Next, let's move on and look at question number 33. This question deals with somewhat deeper physical concepts. I can explain that this is a pattern not particularly related to the SFE exam. This type of question asks how to express intensity measurements using the logarithmic method. The term itself is a bit difficult, isn't it? So just remember that the correct answer is decibel. You should also note that going into detailed, in-depth content isn't important for preparing for this exam. Next, let's move on and look at question number 34. This is a point I also emphasized in the physics theory lecture. Yes, you can see this as content related to prefixes. It's about choosing an option that can be expressed as 10 to the minus third power. If you look for the correct answer, you'll see that it's related to the term milli in option B. So, when a specific value comes up, it's important to know how to express this unit differently, and I can say that you need to be familiar with these prefixes. Let's move on and look at question number 35. If you look at the question, it's about choosing the sentence that defines frequency in ultrasound waves. In this case, rather than looking at each option in detail, it's more efficient to find the correct answer right away and then review the definition of frequency. If you look for the correct answer, option C, number of cycles per second, is the sentence that best describes frequency. Next, let's move on to question 36. This question is also related to unit conversion. It defines Doppler ultrasound, stating that the PRF, or pulse repetition frequency, is displayed as 13 kHz. The question asks you to find a unit that can be expressed in the same way as this. At the end, it's given in kilohertz. Since kilo means 3 zeros, you can choose the answer in the options that says 13,000 Hz. Let's look at question number 37 right below. This is something I explained in the previous lecture. This question asks you to find the term for the section where pressure increases as the wave propagates. If we select the correct answer right away, it would be compression, as shown in option A. On the other hand, the section where the pressure drops is called rarefaction, which is option C, so please remember that once again. Let's look at question number 38 next. The frequency increased from 2.5 Hz to 5 Hz, which is about double. This question asks how the wavelength changes in such a situation. You could see this as a simple calculation problem, but it's a pattern you can only solve if you know the basic concepts. Yes, I'd like to emphasize again that this is an important and frequently appearing question type. When the frequency increases, the wavelength on the other hand decreases. Since the frequency has doubled, the wavelength, conversely, will be halved, so you should choose option C as the correct answer. Let's look at question number 39 next. Looking at the question, it's asking you to calculate what the period would be when the frequency is omega hertz. The period in this case has the characteristic of being inversely proportional to the frequency. Since it's omega hertz and in megahertz, there are 6 zeros after the number. Among these, the numerator above is set to 1. If you calculate this value, you can find the period. The important point is that you don't calculate the value directly using the O, but since it's in megahertz, you need to add the appropriate number of zeros for the unit at the end and then calculate the value. If you use this value to find the period, you'll get the value shown here. To emphasize once again, when solving calculation problems, it's important to check the units first and then proceed with the calculation. Let's move on and look at question 40. This question also asks about basic concepts. It asks about two factors related to wavelength. If you know the formula for wavelength, this problem can be solved easily. Wavelength can be considered as the speed of the wave divided by the frequency, so these two have an inversely proportional relationship. Looking at the answers, option D is related to frequency and wave speed. Therefore, you can choose option D as the correct answer.